All right, this video is going to talk about how to use factoring in order to solve equations. So the first thing we want to remember is how to solve an equation, what the goal is in solving an equation. If you take a good look at the examples on the screen here, the equation on the left is fairly easy to solve using some basic terms and basic skills. If I've got a 6x minus 5 and we're equal to 49, the first thing I want to think about is the last step happening in our order of operations is this subtraction, right? Subtraction would have come after multiplication over here on the left. So if I want to get rid of that minus 5, we're going to add 5. Right? Because very simply, 6x minus 5 plus 5 leaves you with 6x. We just cleaned up that left side just a little bit and leaves us with 54 on the right. Well, in order to get rid of a multiplied by 6, we're going to divide by 6. And since I can easily get x by itself, right, we can find that if x were 9, we'd have a great solution to that equation. The same thing works in the middle. Again, we've got 5 times x, so we can go ahead and divide by 5, and realize that 0 divided by 5 is still 0, and we've got a great answer there. And that makes total sense. The only thing you could multiply by 5 to get 0 would have had to been 0, right? We would have had to multiply by 0. Well, that same idea is going to be incredibly helpful for us for this next problem, because the problem is I can add that 20 to the other side, similar to the first example, and try to do it that way. But the problem I run into now is I have two different terms that have x's in them. How am I supposed to solve this when I can't combine those? They're not like terms, right? One of them is an x squared, and the other one's an x to the first. But I can't get them by themselves then if there's two of them. And the reason we can't do that is because quadratics, or polynomials where there's x squared, they take a little bit more work. They take a little bit more effort. But because we've already learned how to factor, right, using factoring to solve, if we split this up, we're going to be able to take advantage of one very important thing. And that's the idea that if this equation is equal to 0, if I can get two things multiplied, right, if I can make this a product equal to 0, then I can split up the two parts. Because similar to that inside, or that middle example we had there, we have what's called the zero product property. If two things, A and B, are multiplied and equal to 0, well then one of the two of them, either A or B, must have been 0. The only way to multiply to get 0 is to multiply by 0. Well, instead of having three things subtracted up here, in that case, I would much rather have two quantities multiplied. Because if that's the case, I can set them both separately equal to 0 and solve. So let's think about what would multiply to negative 20 that also adds to negative 1. Well, to multiply to 20, we can be 1 and 20. We can be 2 and 10, or we can be 4 and 5. Those would be our only factors. To multiply to a negative number, one of those numbers needs to be negative. And to add to a negative number, it better be the larger of the two. So I'm going to make the 5, the 10, and the 20 all negative. And the only pair that adds to negative 1 is going to be that 4 and 5. So let's split up this trinomial into x plus 4 and x minus 5. Well, that means that, again, either x plus 4 equals 0, just like saying a could be equal to 0, and it wouldn't really matter what the other part is, right? If that turns to 0, anything times 0 is 0. Or x minus 5 could equal 0. Because, again, if x minus 5 equals 0, if, say, x were 5, right, if we added that 5 to the other side, well, this becomes 0 multiplied by whatever that is, 9, right? And 0 times anything, 0 times 9, would be 0. Let's make sure we solve this other equation here. So x could have been negative 4, or x could be positive 5. Either one of those would help us solve that equation. And that's the main idea of using factoring to solve. If you can have two quantities, like x minus 2 and x plus 3, equal to 0, then what we can do is split them into two parts, because one of the two of them, either x minus 2 had to be 0 or x plus 3 did. And in that case, we'll add our 2 to solve our first equation. We'll subtract our 3, right, to solve our other one. So if you have an unfactored problem, like the one down at the bottom, what we need to do first is think, okay, what multiplies to 6 and adds to 5? Well, multiplying to 6 is 1 and 6, 2 and 3. Only 2 and 3 are going to add to 5. So let's write a couple of factors, x plus 2, x plus 3, still equal to 0. Don't forget your equation, still equal to 0. Because now, multiplied to 0, either x plus 2 or x plus 3 equals 0. And in that case, we can subtract our 2 and subtract our 3, and we'll get our two answers of -2 and -3. The same thing works with monomial factoring. Notice this problem at the right. We've got a 3 and a 12. So I can factor out a 3, and at the same time, I can factor out an s, because there's an s in both parts. So if 3s is my greatest common factor, that would leave behind an s minus 4, right? 3s times s would have been 3s squared. 3s times -4 is -12s. And if we've got 3s times s minus 4 equal to 0, then one of the two of those needs to be 0. Divide by 3 and add 4. Again, dividing by 3 on this side, s equals 0. Adding 4 in this equation, s equals 4, and we've got our two answers. So that's a great way to solve a quadratic or an x squared style equation. Now, we can use this for some application problems. This is what's called a vertical motion model. And you can pause the video, read through the problem, but I'm going to kind of keep moving forward. What a vertical motion model says is that the height of a penguin at any given time would be equal to -16, which is essentially gravity pulling down on that penguin, plus its initial velocity as it left the water. For us, this is 4.5 feet per second, and plus its initial height. Well, if it's leaving the water, its initial height would have been 0. So our question is, find the zeros of the function. Well, remember, that's not when it's saying plus 0. A zero of a function is saying, when are we equal to 0? Well, if our equation is equal to 0, we can factor. That's a great time to factor things out. And notice there's a t in both parts, so I'm just going to remove that t. Oops, not a t squared anymore, because again, I took out the t. And now, either t equaled 0, which we knew that at time 0, the penguin was leaving the water, right? What I really want to know is at what time is he re-entering the water? Well, that will come from our other side of our equation here. 16t plus 4.5 equal to 0. Well, -16t, I'm going to subtract that 4.5 to the right. I'm going to divide by my -16, and t will equal. Well, if we go to our calculator here very quickly, we get to our main screen, -16. Oops, clear. We wanted 4.5, right? 4.5 divided by, I just want to double check my numbers here. Yeah, -4.5 divided by -16, and we get 0.281, 0.281 seconds, which makes sense. If a penguin comes flying out of the water, it's not going to be out of the water for very long. It's going to jump out of the water. And again, tell what that function meant. Well, it meant that the penguin was out of the water for about 0.281 seconds. Now, one very important thing when you deal with these equations is that it's only really helpful to try to factor when we're equal to 0. So one thing we would want to do when they look a little bit funny is make sure we set ourselves equal to 0 first. So I'm going to subtract this 15n, right, over to the other side. 6n squared minus 15n would be equal to 0. And in that case, I can factor out a 3n. I know a 3 goes into both 6 and 15. 2n times 3n is 6n squared. And 5n, or 5, sorry, times 3n would have been negative 15n. So in that case, either 3n equals 0 or 2n minus 5 equals 0. Divide by 3 and n equals 0. Or if we add 5, 2n equals 5. Divide both sides by 2, and 5 halves would be our other answer. So 0 and 2.5 would be two good solutions. Again, the same thing goes over here at the right. First, I want to kind of clean this side up. I'm going to take x squared plus 34x, but at the same time, I may as well bring this 62 over to this side. So that'll be a minus 72. In that case, I'm going to think about what would multiply to 72. So 1 and 72, 2 and 36. But again, I'm multiplying to a negative and adding to a positive, right? So I need one of my numbers to be negative, and it better be the smaller number because I still want to add to a positive. Well, 72 plus negative 1 is 71. That's way too big. But 36 plus negative 2 would be 34. So I can say x minus 2, x plus 36 equals 0, which means either x minus 2 equals 0 or x plus 36 equals 0, right? One of those two factors has to equal 0. Let's add 2 to both sides. And in the second equation, let's subtract 36 from both sides, and you'll find that you get your two answers. And if you don't trust your answers, again, you could always plug them back in and check your answer. It's not a bad idea to begin with, but you could plug those in very quickly and make sure that you get 62 from both of those answers. The last thing we want to mention is just what if we wanted to go backwards? Well, if I know my answers are x equals 7 and 8, think about sort of setting up. If I subtract 7, x minus 7, and 7 minus 7 would have been 0, I can make factors, right? I can make those x minus 7s. So I got one factor right here. In the same way, if I subtract 8 from x, wouldn't 8 minus 8 be 0? So again, x minus 8 will be my other factor. And if we want to have this in standard form, all it takes then is a little bit of FOIL. Minus 8 and minus 7 would add to a negative 15x, and negative 7 and negative 8 would multiply to 56. Don't forget to be equal to 0, because again, we're trying to set up an equation, right, that would have these two solutions. In that same way, x minus 9, now 9 minus 9 would be 0, right? And x plus 4, isn't negative 4 plus 4 going to give us 0? Well, in that case, I need an x minus 9, an x plus 4. And if I FOIL, x squared plus 4x minus 9x, well, positive 4 and negative 9 add to negative 5. And finally, minus 36. We've got a standard form equation with the given solutions. If you have any questions about factoring to solve equations, make sure you talk to your teacher. Otherwise, have a great day.